In this video, we are going to answer the question, how do we find percentages? We're going to learn two different ways of doing this. We're going to learn the table method, and then we're going to learn the multiplication method or the translation method. So let's take a look at a percentage problem. Usually they come in the form of word problems. We're going to take a look at a percentage word problem, and we're going to look at two different ways of solving that same word problem. So this is a common problem that you're going to see. It's going to be looking just kind of like this, and this is the easiest of the common ones that you'll see that you will not be able to use a calculator for on the IAB or the SBAC, so you need to know how to do these without a calculator. 6% of 36 is blank, and we can do this one of two ways. I'm going to do this using the translation method, and then simultaneously I'm going to show the table method. So 6% of 36 is, the first thing that we want to do is we want to do something called translate. So we're actually going to translate what we are doing into math terms. So we're going to go ahead and take these arrows and we're going to work vertically, meaning we're going to be working going down. This will make it easy for us to keep track of what we're doing and also be able to look up at what we last did so that we can fix any mistakes that we might have. So we're going to translate this. 6 is already in number form for us. Percentage, 6% is going to look like that. That's how we can start it like this. And of is going to translate to multiplication. 36 is just a number, and is equals. Okay, that's what it means for is. Now we got a little bit more to translate here because 6% needs to be in a form that we can actually use to multiply by 36 without using a calculator, okay? So we need to know what 6% looks like in numerical form or fraction form. And because it's 6%, it's not 100%, we know it's not going to be a whole number. And if you look back at the last video, which is what is a percent, you would quickly be able to tell me that this is actually 6/100ths. Because 6 over 100 is equal to 6%. And again, percent means by 100. Check out what is a percent video if you're not understanding the language that I'm using right now. We can keep everything else the same, making sure to use those arrows, excuse me. And then we're going to drop down the multiplication symbol, and we're also going to convert this 36 into a fraction by putting it over 1. This is going to allow us to do some easy multiplication here. So we're going to go ahead and multiply 6 times 36. So 6 times 36. They won't let you use a calculator, so if you can't do this in your head, which I can't, so I'm going to do it here. So we know that 6 times 6 is actually 36. Bring over 3. 6 times 3 is 18. Add the 3 back in. 19, 20, 21. 216 is the answer for 6 times 36. And multiplication for fractions, of course, we just go straight across. That's why it's nice and easy. So we have 216 over 100. Now we're not done there. We actually need to take this over here and we need to interpret this as a division problem. And this, since we're dealing again with powers of 0, this is a really easy multiplication problem. We know that if we want to get 216 from 100, all we got to do is times it by the same thing we had times 1 by and just move around the decimal place. So if we took out these zeros and we imagined these without zeros and we just had a 1, we would say, okay, then our answer has to be 216 because 1 times 216 would equal 216. However, there are 2 zeros, so what we want to do is put the decimal place here and then show that we know that it is 2 zeros over. And so the answer to this is 2.16. So 216 divided by 100 is 2.16. And that means that 2.16 is 6% of 36. 2.16 is 6% of 36. Now, most of the problems that you're going to see are not going to be as simple as just being able to translate straight across. And the reason is they want to know that you can kind of find things that are out of place. So they might ask you things like blank percent of 36 is 2.16. So they might flip it on you, and you would have to solve for this. And so you would have to do kind of everything backwards. You would be given the information here, but not the information there. And so you have to work your way through it in a similar manner. And we can go through that real quick because you did already solve for this just straight across as if it was a regular multiplication problem that you're used to. This is different. This is solving for an unknown. We don't know what the percent is. We're given the total. We're given the percentage, but we don't necessarily, or we're given the, we're given the part of that whole. The cool thing with this one, though, is that you can actually just solve by putting this as a division problem. So you can just say 2.16 over 36 is going to give you your percentage answer. And that you can do that with anything. And that's because if you remember, a percentage looks like this, right? If we say 10%, that's what 10% looks like. It's 10 over 100. So it makes sense that it works in this case too. But what does that mean? That means that we have to, excuse me, we have to interpret this as a division problem, which means we have to say that is 2.16 divided by 36, which is equal to, how many times does 36 go into 2.16? So we're just going to pretend that for right now, this is 216, and we want to see how many times 36 can go into 216. We know if you multiply 33.333 by 3, you're going to get very close to 100, okay? It's not quite 100, it's like 99.9999, but it's very, very close to 100. You could safely round up to 100, and nobody would fault you for it. In fact, millions of our transactions that are happening a year do that same exact thing. They round up. So we see that if 36 or 33.333 goes into 100 3 times, then we know that 36 can go into 216 more than 3 times, but how many more can it go in? That's the big question. And we can actually just look at 36 times 4 as a nice starter because it's over 3, but it's only over by 1, and then we can judge from there and see how many more we need. Okay, so 36 times 4, that's 6 times 4 first, which is going to give you 24. And then you're going to have 4 times 3, which is 12. Add back the 2, you're going to get 14. So you're going to get 144. We have quite a bit left, but we know we're not going to be able to have 3 more times of 36. And if we multiply 36 by 2, we know we get 72. And so are we able to add 72 into 144 without going over 216? Let's try. So just make that clear, 36 multiplied 2 times, or by 2, is equal to 72. So we're trying to add on plus 2 to this number, which would mean we'd have 36 times 6. So let's see here. 6, 7, 8, 9, 10, 11. Oh, wow. So we figured out that 36 times 6 equals 216. We found that out over here. So all that's left for us now is to plug in where our decimal place would be had we actually have treated this as 2.16 or 2 and 1600ths. Instead, we treated this like 216. So we got to make sure that we move the decimal place over 1, 2 in order to account for the fact that we did not use the decimal when we were dividing. We just made it easier on ourselves and treated this as 216. So we're going to go ahead and go over 1 and then 2. A good trick sometimes, if you have really neat handwriting, is to make sure that you can always put the decimal place back where it's supposed to go. But I like moving it and shifting it. It just is a little bit more time to check if you are correct. And then, of course, you have to fill in the 0, because if that decimal place is that many times over, it's no longer 6. It is now 600ths, which we know is 6 over 100, which we know as 6%. So that is another way that they might show you the problem. And I doubt, honestly, that they're going to show you any problem that is this drawn out. Usually they try to stray away from things that have really long, never-ending numbers. I just made this up, and so it's probably going to be a lot harder than any ones that you see. And there's not a ton that are really easy, and so I can't really choose from the ones that they have and change it, because all kinds of stuff happens when you change it. So let's take a look at a new problem, 2 different ways, just like we saw this way, and we'll look at just the table method of solving, and I'll explain that method right now. So we're going to do an easy one like we did up there, and we'll go ahead and do what is 39% of 719. So this time we're going to do the table method, and you can start by drawing yourself a table. Now I'm going to pause right here because sometimes I lose people, and I really want to make sure that you're still with me and that you have your math journal out and that you're copying what I am doing down. You're also writing questions on things that you don't understand. That way, when we come back together, I can answer any of those questions and we can have an intelligent conversation about the difficulties that you're having. There's nothing wrong with struggling at math. It can be a difficult subject, especially when we can't relate to the numbers that we're being asked to manipulate. However, it's no excuse not to grow each and every day and to face new challenges. So I encourage you guys to follow along with me, copy what I copy down, and write down any questions that I have. If you're struggling to write down your questions, remember you can use the sentence frame, I wonder. And after you say or write I wonder on your binder paper, you can then write what you're wondering about. Maybe it's, how did I get a certain number? What step did I do next after a particular step? So make sure that you are engaging with this video and not just passively watching it. I'm going to keep the sentence frame up there just in case you want to use it. So we're doing the table method, and we should have drawn our table already. I'm also going to draw some spaces, some rows going across to give us 2 columns. Again, just a refresher of our vocabulary here. Columns are up and down, and rows go from left to right. So we want to make sure we have that jargon down when we're discussing especially strategies like equivalent ratio tables. So remember, we're dealing with part to whole ratios here, and we know since we're dealing with percent, one of those wholes has to have 100. Why does it have to have 100? Because percent means by 100ths. Okay? You are literally saying by 100ths when you say percent. Per equals by, cent equals 100. Okay? So that is why we put 100 as the whole. Anything over 100 is that percent. That's 6%. That's 7%. This is 80%. This is 90%. This is 100%, which means it is 1. 100% does not mean 100. It means one whole. So when we think anything less than 1, we can start thinking percents. 1 is greater than 99%, believe it or not, because of our little friend place value. And if you don't know what I'm talking about there, you are too far behind, and you're going to need to go back a couple videos. So we know our whole because we know we're dealing with percentages, and it says it here. And so we can now plug the part in. Again, this is equal in this ratio table to 39 over 100, which of course, as we just looked at, is 39%, 39 hundredths. Percent means by 100. So we have the whole, which is, you guessed it, 719. So we can go ahead and plug that in now. Now, you might be saying to yourself, well, what step is next? Well, now we can just do our easy peasy routine of seeing, okay, well, how did I get from 100 to 719? Well, that is an easy one. We should know this by now. Because we're working with powers of 0 here, we can just assume and know that all we got to do to figure out what we had to multiply 100 by to get 719 is go and take our decimal back 2 spaces because we have 2 zeros here. So we go 1, 2, we're left with 7.19, which means whatever we have done to one side of our table, we have to do to the other side of the table. So if we multiplied 100 by 700 or 7 and 19 hundredths, then we have to multiply 39 by 7 and 19 hundredths, which you can start to see. This is not any easier, nor is it any harder than the other method that was shown. Okay, it's just a different way, and it's really whatever way you feel comfortable with. I don't want you to do any way you don't feel comfortable with. I want you to do the way that works for you. It also helps, though, to have multiple ways. So we're going to do the multiplication here because you're not going to be able to use a calculator on these problems. So we're going to go ahead and go 9 times 0 is 0, 9 times 0 is 0, 9 times 9 is 81, so we can put the 1 here and bring the 8 over here, and then we have 3 times 9, 27, but we have to add that 8 back in, so we can go ahead and add that 8 into 27, and let me just get that eraser out of the way. So if we add 8 into 20 plus 27, we have 3 with 5 remaining, so we have 35, I believe. I hope I'm not wrong. And we will continue down the line. I like to put an X to know that I'm moving to the next place value. So we are moving, as you can see, we went from the hundredths, and now we're moving to the tenths. So I like to make an X to say that I'm moving on. So 1 times 0 is 0, 1 times 0 is 0, 1 times 9 is 9, and 1 times 3 is 3. And then I will put an X and then another X because I have finished with the tenths place and I am moving on to the ones place. So we're going to go ahead and multiply the ones by everything that's on top. So we got 0. 7 times 0 is 0. 7 times 0 is 0. 7 times 9 is 63. We can go ahead and put the 3. Get the 6 over here. 7 times 3 is 21 plus 6 is 27. Then we can go ahead and add. We got a lot of zeros here, and that's okay. We could have done 719 times 39 and then just manipulated the place value, but let's just do it this way because it's less that I have to talk about and explain because the focus really should be on using this table, and this is sort of expected at this point by you. So we got 0, 0, 1, 14, 4, 5, 6, 7, 8, 9, 10, 8, and 2. So that gives us a really big number, but we got to remember that we have our place value markers here. So 1, 2, 3, 4. 1, 2, 3, 4, which means we put the place value where we thought it would be and then go 1, 2, 3, 4. So we get 280 and 41 tenths, 41 hundredths is 39% of 719. So 280 and 41 hundredths is 39% of 719. So let me just make sure that answer is there. And then I don't really have the answer for that problem, so I'm just going to check my work on the calculator. I can kind of tell that that looks pretty close because I know that half of 719 is going to be somewhere around 364.5, and that would be 50%. So I know that this looks pretty logical, but I'm just going to check it on the calculator just so I'm not giving you false information without doing my due diligence. So I'm going to go, the thing that I'm going to type in the calculator, guys, it's really easy. In fact, I'll go ahead and I'll display that right now. So here it is. I went ahead and did it on the calculator. I just entered in the number 280 and 41 hundredths, and I divided that by 719, and it equaled 0.39 or 39 hundredths, which we know to be 39%. So 39% of 719 is, in fact, 280 and 41 hundredths. So not too difficult. And some of you who are more advanced in your knowledge of mathematics and place value, which is not all of you, would be able to make simpler work of this multiplication problem for sure. We wouldn't have had to end up with all these zeros. We wouldn't have had to go through all of this. So we would have only had 2, because we could have just done 39 times 719 and then just manipulated the place value. But that is the way that we do it. So we can, or you can decide which method you prefer. But we're going to look at the table method again using this problem, but in reverse order, just like we looked at the last problem. So I want us to do that. So let's go ahead and scroll down and do that now. All right, so if you've been with me this whole time and you worked with me through that last problem, congratulations. That was a 7th grade math problem, and it actually recommended using a calculator on it. And that made sense to me because I really don't think that they're going to have you with any decimal places for these questions. However, none of this is outside your skill set as 6th graders, but I'm going to give a little bit easier problem to work with per recommendations from this website that I visited. So I'm going to use this one to show us both ways. So I'm going to show us the way that they usually start off with, and then the more complicated way where they're reversing it on you. So I'm going to go ahead and write it in, and it's going to be what is 70% of 48. And so we're doing the table method, so you should go ahead and draw your table. I know those of you who are still with me are copying this down, because those of you who don't copy this kind of stuff down, there'd be no way you'd be able to stay this engaged for this long. So let's go ahead and put in our part and our whole, and we can give a few more rows to this. And we know that we have our part, which is 70%. We know we have our whole, which is 100%. And we have our other whole, which is 45, okay? Oh, excuse me, 48. And we got that from here, this from there, and 100 is because that is a percentage sign. And percent means, you guessed it, by 100th, okay? So now that we have all the information we need filled in, we can start looking at our table relationships that we have going on. So let's take a look at this, and we can actually do some fancy stuff here so that we can interpret this as a division problem to get our first relationship going. So this is equal to 48 divided by 100. I just want you to know that. But we know that 48 over 100 is equal to 0.48 because it is 48 hundredths. That's what you're saying when you have any number over 100, right? So we know that this is 0.48. So we know that we had to multiply 100 by 4.8, or excuse me, by 48 hundredths to get 48. So what we do on one side of our table, we have to balance and do to the other side of the table. So now we have to multiply 70 by 48 hundredths. And so there's several ways that you can tackle that, but it's not a difficult multiplication problem at all. You could do different techniques with the zeros and the place value, but to make things simple for us, I'm just going to do 70. And when I mean simple for us, I mean whole group simple. And we can just multiply like we normally do. 6 and go ahead and put our x here so we know we're moving over to the next place value. And we got 0, 0, 0, 28. We'll add that up. 6, 13, 3. And then let's go and count our decimal places. We got 1, 2, 3, and 4. So we put our decimal here and we'll just go 1, 2, 3, and 4. So our answer ends up being 33.6. So 33.6 is 70% of 48. Now, I want to show you what we would do if something was in a different order. So let's look at if the question was asking 33.6 is 70% of what number? And this is a very common one. They just kind of flip it on us, right? And right now, we know the answer to that because we have this completed table again, but we don't have that luxury in the SBAC. So we're going to go ahead and this is our last problem we're going to solve together because the time is running on. So we're going to solve it the same way by making sure we have our table. We're going to have a part and a whole section. You can start plugging in the numbers from here and here. And so we know part for a percentage is 70 and the whole is 100. And then 33.6 is the other part that we don't know what the whole is, or we're pretending we don't know what the whole is. So we need to get the ratio relationships here. So we can actually get the value of the ratio here to figure out what we are going to divide 100 by to get our missing number. So we can go ahead and say this is 33.6 over 70, which is 33.6 divided by 70, which is equal to how many times does 70 go into 33 and 6/10. And we're going to treat 33 and 6/10 like 336 for this long division problem. And we're just going to see how many times does 70 go into 336. Well, 70 can be looked at like 7, and we can just add that 0 back later. So I'm going to have you guys visualize that. So if we're talking sevens, we know that 3 times 7 is 21. We know that 4 times 7 is 28. And we know that 5 times 7 is 35. So we know that after 4, we go over what this number could be. So we can't do 5 because that would be 35 and it would go over 33, okay? Because remember here, we are adding that 0 back in to 70, okay? So we want to say how many times does 7 go into 336? Goes in to 33 4 times. So we got to make sure we put the 4 in the right place. The 4 should be going here because we are doing 7D times 4. We just took away the 0 so that we could make it easier for conceptualization purposes. So we do have 70 times 4 is equal to 28 plus adding the 0 back in. So now we can just go ahead and subtract to see what we have left here. We got 6, 2, 13, we got 5, so we got 56. And we cannot get 70 into 56. 70 is bigger than 56, so we got to bring in our zeros just to show that there's nothing in the hundreds place. So we drop down that 0. And then we see how many times does 70 go into 560, or rather, how many times does 7 go into 56? Because we have zeros now, so we have the power of 0 at our disposal. So we know that 7 times 8 is 56, or 5, 6, 7, 8. That's how I remember it. And you can go ahead and put in the 8 here. And the last thing we want to do is we just want to bump that decimal point up so that we know that it is 0.48. So now we have the value of this ratio. So now we know that we can multiply 70 by 0.48, and that gives us 33.6. So we had to multiply 70 times 48 hundredths, and that gave us 33.6. We did that by reversing it and doing the division to figure out what we needed. So now we have to do the same thing that we did to the part side to the whole side. So just like we multiplied 70 by 0.48, we are now going to multiply 100 by 0.48, or 48 hundredths. And we know that if we multiply things by 1, we're going to get that number, and that's really no different when it comes to 100. It's just a different place value. So we're just going to be moving the decimal points over to indicate that it has been multiplied by 100, or 2 powers of 10. So we'll take that decimal, because we have 1, 2 zeros here, we'll go ahead and move that decimal over 1, 2, and that gives us 48. So we can go ahead and plug in 48, and that should be our answer. Yes, it is. So working backwards is no more complicated. It's just all about these ratio relationships. Really finding the value of a ratio is going to allow you to figure out how to balance out your ratio table. So if any parts of this you did not understand, you need help, or get stuck on, make sure that you're copied down into your notebook, and then we can go over them together during our win-win time.